Chapter 4 covers services. The service is the electrical supply in the form of conductors and equipment that provides electrical power to the building or structure. The service conductors for the building or structure are either overhead drop or underground lateral conductors. The local utility company brings electricity to the service point. All electrical connections, equipment, conductors, etc. beyond that point are controlled by the NEC. Upon completing this chapter, you will be able to define the common terms associated with services, describe the limitations on unprotected service conductors per Article 230, identify important requirements for building services installation, identify requirements for overhead service drop conductors, describe the use of a service mast, and explain underground service lateral conductor and service entrance conductor ratings. Describe service entrance conductor protection. Identify requirements for providing disconnecting means for service entrance conductors. New in the 2014 NEC, new requirements for conductors considered outside the building, Article 230.6, revised service masts as supports, Article 230.28, list of permissible underground service conductors, Article 230.30. Requirements for minimum size of service entrance conductors revised, 230.42. Labeling requirements revised for cable tray for service conductors, 230.44. New requirements for meter disconnect switch markings, 230.82. The service is the electrical supply in the form of conductors and equipment that provides electrical power to the building or structure. Note that the source of supply for the service must be from the utility. Service is the root word for 8 other terms that are defined in Article 100. It is a general term and usually includes the underground service or overhead service conductors, service equipment, and any associated metering equipment. A service conductor, overhead, is a conductor that connects the service equipment from the building or structure with the electrical utility overload supply conductors at the service point. This connection usually occurs outside of the building or structure. A service entrance conductor, underground system, is a conductor that connects the service equipment with the service lateral or underground service conductors. The informational note following the definition of underground service entrance conductors in Article 100 points out that in some electrical service installations there may not be any service entrance conductors. In other installations, the service entrance conductors may not even enter the building. This depends on the configuration of the service and the location of the service disconnecting means. The service drop is the overhead conductors between the service point and the utility electrical supply system. Usually the service drop conductors originate at the last utility pole or aerial support and continue to their point of attachment on the building or structure. Utility companies frequently use triplex or messenger cable assemblies as the service drop conductors to the building. In many of these systems, the steel messenger cable is used as the grounded or neutral conductor for the premises wiring system. The service lateral is the underground service conductors that connect the utility's electrical distribution system and the service point. The utility supply system can originate from a pad-mounted transformer or an overhead supply system with the conductors emerging from the ground and continuing up the pole. The service point is the point of connection between the local electrical utility company and the premises wiring of the building or structure. An important design consideration in any electrical distribution system is the point at which the utility supply ends and the customer-owned or premises wiring begins. The NEC typically only applies to the premises wiring. Service equipment is all of the equipment necessary to control the supply of electrical power to the building or structure. It includes circuit breakers, fuses, disconnecting means, panel boards, etc. All equipment used as service equipment shall be identified as being suitable for use as service equipment and shall be listed per Article 230-66. Listing and labeling equipment as suitable for use as service equipment is one method to determine that the equipment is identified. Individual meter socket enclosures are not considered service equipment and need not be identified. The general rule of Article 230.2 limits each building or structure to a single service. Subsections 230.2a, b, c, and d are intended to provide some latitude for the designer and installer for a particular type of occupancy or for a particular type of system. Subsection E of Article 230.2 contains important marking and identification requirements at the service disconnecting means where a building or structure is supplied by more than one service. Although service conductors are not provided with overload or short circuit protection, there may be installations in which there is a need to have service conductors enter the building. Many high-rise distribution systems with large power needs utilize Article 230.2c to bring a second service into the building. Often, the second service is run to an upper floor electrical room for distribution to the upper floors of the building. In these types of installations, the service conductors enter the building without overcurrent protection. While Article 230.3 prohibits service conductors from being routed through the interior of the building, the 5 provisions found in 230.6 provide methods that allow service conductors to be considered outside of the building. Only service conductors shall be installed in service raceways or service cables. Service raceways are not defined in Article 100, but is considered to be any raceway that contains service conductors. Allowing only service conductors to be installed in service raceways ensures that a fault of any type in the service raceway will not affect other conductors. Per Article 230.7, Exception 1, this does not apply to the grounding electrode conductors, equipment bonding jumpers, or conductors which are permitted within the service raceway. Per Article 230.7, Exception 2, load management control conductors are also exempt from this general rule. These control conductors are permitted within the service raceway if they are provided with overcurrent protection. Because service conductors are not protected by overcurrent protective devices, additional care is taken to ensure that the conductors are not accessible to the general public. Per Article 230.9a, whenever service conductors are installed as open conductors or as multi-conductor cable without an overall outer jacket, a clearance of 3 feet shall be provided from windows that can be opened, doors, porches, balconies, ladders, stairs, fire escapes, or similar locations. The intent of this is to protect people from possible contact with these conductors by maintaining a 3-foot zone around the conductors. Vertical clearance for the final span above or within 3 foot measured horizontally from platforms or other surfaces from which the conductors could be reached shall meet the requirements of Article 230.24b. Overhead conductors that connect the utility system to the service point are service drops. An example of a structure that could be supplied by a service drop is a pole. In this case, the service point is located at the point where the service drop connects to the service entrance conductors. If, on the other hand, the service point is located at the utility system point of connection, for instance the top of a utility pole, the conductors from the service point to the service disconnecting means on the private pole are overhead service conductors. Overhead service conductors shall have an ampacity that is adequate for the intended load. The load is determined based on the calculations required by Article 220. Another general consideration for overhead service conductors is that they have adequate mechanical strength. Overhead service conductors are often subject to severe weather conditions, which can put a great strain on the conductors due to the additional weight. Likewise, overhead service conductors are sometimes subject to long spans, which also increase the stress on the conductors. For this reason, Article 230.23b sets a minimum size of number 8 copper, number 6 aluminum, or copper-clad aluminum, for most overhead service conductors. While some installations for limited loads of a single branch circuit allow the size of the overhead service conductors to be reduced, they are not permitted to be smaller than number 12 hard-drawn copper or equivalent per Article 230.23b exception. The general rule for overhead service conductors requires that they be installed so that they are not readily accessible. Overhead service conductors shall not be easily reached. They shall not be installed so that they can be reached without the use of a ladder or portable means. This requirement does not pose a problem for most installations. One area of concern, however, is when the overhead service conductors pass over the roof. Per Article 230.24a, overhead service conductors shall have a minimum vertical clearance of not less than 8 feet above rooftops. If a roof is subject to pedestrian or vehicular traffic, such as in the case of rooftop parking garages, Article 230.24a Exception 1 requires that the minimum clearance from the roof surface conform to the requirements of Article 230.24b number 4. Therefore, in this installation, the minimum clearance above the rooftop is 18 feet. For services of less than 300 volts between conductors, the required clearance is permitted to be reduced to 3 feet. Per Article 230.24a Exception 2, provided the slope of the roof is not less than 412. Article 230.24a Exception 3, a further clearance reduction is permitted for services not exceeding 300 volts between conductors when not more than 6 feet of overhead service conductor passes 4 feet or less horizontally above a roof overhang and the conductors are terminated in a through-the-roof raceway or approved support. If both of these conditions are met, the minimum clearance can be reduced to 18 inches above the overhang portion of the roof only. Article 230.24a Exception 4, the 3-foot vertical clearance from the edge of the roof does not apply to the service drop or to the final span of overhead service conductors when the conductors are attached to the side of the building. This exception is necessary for installations in which the overhead service conductors attach to the side of the building at an angle which does not permit the 3-foot clearance in all directions to be maintained. The second type of clearance that shall be maintained for overhead conductors is vertical clearance from ground. The requirements for 230.24b establish 4 different clearances based on the voltages of the overhead service conductors and the type of traffic over which the conductors are installed. A service mast is an assembly consisting of a service raceway, guy wires or braces, service head, and any fittings necessary for the support of overhead service conductors. Service masts must be designed to support the weight of the overhead service conductors under varying conditions, including those when snow and ice may add additional weight to the conductor span. Underground service conductors shall be sized to handle the calculated load per Article 230.31a. The load shall be computed per Article 220. In addition, the underground service conductors shall have adequate mechanical strength for the application. To ensure that the conductors have adequate mechanical strength, Article 230.31b requires that the minimum size for underground service conductors be number 8 copper or number 6 aluminum or copper-clad aluminum. Per Article 230.31b, the exception, the minimum size conductor permitted to be reduced to number 12 copper or number 10 aluminum or copper-clad aluminum, when the load served consists of a single branch circuit only. The general rule for sizing service entrance conductors is that the conductor shall have an ampacity per Article 310.15 that is suitable for the computed load. The load for the service entrance conductors shall be calculated per Article 220. Just as Article 230.2 limits the maximum number of services for a building or structure to 1, the general rule for 230.40 limits the maximum number of sets of service entrance conductors that can be connected to a single service drop, a set of overhead service conductors, a set of underground service conductors, or a service lateral to 1. There may be, however, installations where it is desirable to supply additional sets of service entrance conductors from a single set of service conductors. Section 230.41 contains specific requirements for the installation of service entrance conductors. Per Article 230.41, all ungrounded conductors that are used as service entrance conductors shall be insulated. The service entrance conductors shall be suitable for the atmosphere in which they are installed. Service entrance conductors are not permitted to be covered conductors. There are 19 listed wiring methods that are permitted for the installation of service entrance conductors in Article 230.43. Wiring methods that do not appear in 230.43, such as type NM cable, are not permitted to be used for service entrance conductors. These 19 wiring methods consist of various types of raceways, cable assemblies, open wiring, and auxiliary gutters. No matter what wiring method is selected, the service entrance conductors shall be installed per the specific NEC requirements for that particular wiring method. For example, if a type MC cable is selected as the wiring method, the service entrance conductors shall be installed according to all the provisions of Article 330 metal-clad cable. All service entrance conductors are required to be protected against physical damage per Article 230.50. Protection is provided by one of 6 means listed in 230.50 B1. Per 230.51a, service entrance cables shall be supported at intervals not exceeding 30 inches. The means of support shall be by cable strap or other approved means. Section 230.54 is located under Part 4 of Article 230, which covers service entrance conductors. These rules apply whether the service entrance conductors are supplied by the service drop or by overhead service conductors. In either case, the overhead service location shall be selected to minimize the possibility of water entering the service raceway. To avoid the entrance of water and moisture, service raceways are required by 230.52a to be provided with a rain-tight service head. The rain-tight service head shall be installed at the point of connection to the overhead service conductors or service drop and shall be listed for use in wet locations. The service head or gooseneck shall be installed at a point that is above the point of attachment for the overhead service conductors. This ensures that water does not enter the service raceway or service entrance cable. However, there may be installations where it is impracticable to locate the service head or gooseneck above the point of attachment. In these cases, Article 230.54c exception permits the point of attachment to be located above the service head or gooseneck. In no case, however, is the service head or gooseneck permitted to be located more than 24 inches from the point of attachment. The purpose of limiting the maximum number of service disconnects and requiring that they be grouped together is to ensure that the entire service or services, as permitted by 230.2, can be shut down at a single location with no more than 6 operations of the hand. Permission to install the 2 to 6 service disconnects gives latitude to the electrical designer, yet provides for a quick interruption of power in the event of an emergency. There are particular installations where application of this rule can be difficult. Motor starting current, for example, can increase up to 6 times the full load running current. In these cases, the overcurrent protective device shall be sized to permit the motor to start. A rating higher than the allowable ampacity is permitted by Article 230.90A Exception 1 when necessary to handle motor starting currents.